Hi guys, welcome to lesson 3.1, Inequalities and their graphs. Our objective for this lesson is that I can write, graph, and identify the solutions of inequalities. Our essential understanding is an inequality is a mathematical sentence that uses the inequality symbol to compare values of two expressions. You can use a number line to visually represent the values that satisfy an inequality. Our vocabulary term, the solutions of an inequality are any number that makes the inequality true. And let's just draw in what our inequality symbols are again. So this one is less than, or equal to. Okay. And then we have greater than, and greater than or equal to. All right, so we're going to start. Let's take a look at problem number 1, writing inequalities. And letter A is all real numbers p greater than or equal to 1.5. So we have p greater than or equal to 1.5. Okay. Letter B, the sum of t and s is less than -3. So we have t, I'll make it a capital, plus 7 is less than -3. Letter C, all real numbers x that are less than or equal to 5. X is less than or equal to 5. And lastly, letter D, for less than a number. So we have for less than a number y, remember that's y minus 4, is greater than 10. Greater than 10. All right, why don't you guys give the next 4 a try? So we have all real numbers y that are greater than 3. Y is greater than 3. Make sure your greater than symbol is very distinct and doesn't look like a 7. The difference of y and 4, y minus 4, is less than 8. Less than 8. Letter C, 4 times the quantity x plus 3 is less than or equal to 11. So the quantity x plus 3, remember that tells us we're dealing with parentheses. We've got addition in there. All right, so we've got 4 times the quantity x plus 3 is less than or equal to 11. Okay. Last one, letter D, the quotient, so we're doing division of x and 7, x over 7, is greater than or equal to 9. Greater than or equal to 9. Okay. Moving on to problem number 2. Problem number 2 has us identifying solutions of inequalities by evaluating. So that means we are going to be plugging them in. So we want to know, letter A, is -3 a solution for 2x plus 1 is greater than -3? Well, let's check it out. 2 times -3 plus 1 is greater than -3. 2 times -3 is -6, plus 1 is greater than negative 3. Negative 6 plus 1 is negative 5. Is negative 5 greater than negative 3? No. All right. How about letter B? Is negative 1 a solution? So let's plug it in. 2 times negative 1 plus 1 is greater than negative 3. 2 times negative 1 is negative 2 plus 1 is greater than negative 3. Negative 2 plus 1 is negative 1 is greater than negative 3. All right, is that true? Yes, it is. So now letter C asks us the question, how is the solution of the related equation 2x plus 1 is equal to negative 3 related to the solutions of our inequality? And it gives us our starting point. Gives us a starting point. So subtract 1 from both sides of the equation. 2x is equal to negative 4. Divide by 2. X is equal to negative 2. All right. So now letter D, we want to know which of negative 1, 0, 1, and 3 are solutions for 13 minus 7y is less than or equal to 6. So we plug them in. 13 minus 7 times negative 1 is less than or equal to 6. 13 plus 7 is less than or equal to 6. So 20 is less than or equal to 6? No. 0, how about 0? 13 minus 7 times 0 is less than 6. 13 minus 0. So is 13 less than 6? No. Let's try our next point. We had a 1. 13 minus 7 times 1 is less than or equal to 6. 13 minus 7 is less than or equal to 6. Well, 13 minus 7 is 6. So is 6 less than or equal to 6? Yes. And lastly, 13 minus 7 times 3 is less than or equal to 6. 13 minus 21, which is negative 8, and that is definitely less than or equal to 6. So you guys go ahead and try the bottom 3, plug those points in, and see if they are solutions to the inequality. So for letter A, we have negative 3 times 2 plus 6 is greater than or equal to negative 4. So we have negative 6 plus 6, which is 0, and yes, 0 is greater than or equal to negative 4. Plug in 5, we have negative 3 times 5 plus 6 is greater than or equal to negative 4. Negative 15 plus 6 is greater than or equal to negative 4. When you add those together, you get negative 9. So that is a no. Last one, 10 thirds. Plug that one in. Negative 3 times 10 thirds plus 6 is less than or equal to negative 4. So that's a negative 10 plus 6. And yes, negative 4 is less than or equal to negative 4. All right, moving on to problem number 3, which is graphing an inequality. So this is where we really need to pay close attention because this is a place that 8th graders tend to make mistakes. So x is less than 1. So I'm going to go to 1. I'm going to put an open dot, open circle. Because is that point connected? Is 1 less than 1? No, it is not. So an open dot tells us that it is not a solution. So that point is not a solution to x is less than 1. Now, which numbers are less than 1? There's two ways that you can approach this. The first way is you can take a test point and plug it in and see if it works. My test point is always going to be 0. So is 0 less than 1? Yes. So that is the side that I color in. Okay. Now, how about x is greater than or equal to 0? So I start off with my circle at 0, but it's greater than or equal to, so it is a solid circle. And x is greater than it. Now, this is one of those times where using 0 as a test point doesn't help, but I could put in any point. Is 5 greater than 0? Yes, it is. So I'm going to shade to the right. If you want to use a marker or a highlighter, you can. So you want to just make sure that it is clear that your line is going to the right. All right, and what do we know about this one? It is that, yes, the point is a solution. Now, for this next one, I'm going to show you a little bit of a shortcut because we have a point at -3, and it is x is greater than -3, and so it's an open dot. The hint I want to give you is that when you have your variable on the left, whatever direction your arrow is pointing is the direction you're going to shade. So if we plug in 0, 0 is greater than -3, so we would shade to the right. And our point is not a solution. All right, the last one, I flipped it around on you guys, so we can't use the shortcut. But we have a circle at -2. It is less than or equal to, so we color it in. So is -2 greater than 0? No, it's not. -2 is not greater than 0. So the 0 will not be part of our solution, so we're going to go to the left. All right. And that point is a solution. Okay. Moving on to the next page, I want you guys to try these next 3 on your own, and then we'll go over the answers. So letter A, we have x is greater than 7. So I have an open dot at 7. And it is greater than, so I am going to shade to the right. Okay. Our second letter A, otherwise known as letter B, we have a -4. X is greater than -4, so is 0 greater than -4? Yes, it is. So we're shading to the right. Last one, 3 is less than or equal to n, so we have our point at 3. And it is a solid dot because it is less than or equal to, so that means 3 is part of the solution set. And we want to use a test point. Is 3 less than 0? No, it is not, so we shade the other side. Okay? All right. Moving on to problem number 4, which asks us to write an inequality when we are given the graph. So I'm going to just use x as my variable all the time. And this is one where we can use this shortcut that I taught you. So the arrow is pointing to the left, and it is an open circle. So it's going to be less than, and the point is at -3. x is less than -3. Okay. Letter B, we have a solid circle, and it is pointing to the right, so it's going to be greater than or equal to. Our point is at 0, so x is greater than or equal to 0. Letter C, we have a solid dot that is opening to the right, so x is going to be greater than or equal to 4, because that's where our point is. All right, I want you guys to try letters A and B on your own, and we will go over them. So, letter A, we have a solid dot at -2, and it is opening to the left, so it is going to be less than or equal to -2. Last one, letter B. We have an open dot, and it is opening to the right, so we have x is greater than. Our point is at -4. So it's x is greater than -4. Last problem of the day would be real-world applications of this. How can we write real-world situations in inequalities? So we have a sign that says the maximum occupancy is 350. So I know our people, x, has to be less than or equal to 350. Okay. Letter B, we have an advertisement from maybe Spirit. And it's asking us, we have a spring sale, and we have fares as low as, right there, $29 one way. So how would we write an inequality for that? We have x is going to be greater than or equal to 29. Because you need to spend $29 or more on your ticket. Letter C and D, why don't you guys try those on your own, and then we'll go over them. Letter C, our school zone speed limit is 20 miles per hour when children are present. So we're going to write our inequality. Your speed must be less than or equal to 20. Okay, and the last one, letter D, the Electoral College map. We know how this one turned out, but in order, if you don't remember, you need 270 electoral votes to be elected President of the United States. So x is going to be greater than or equal to 270. All right, that's the last problem in our notes for today. Make sure you guys fill out your rating scale, and make sure you guys write in your summaries. All right, hope you guys are filling these notes out while you are watching the Cubs game. We will see you all on Monday. Go Cubs.